I'm Baylor Hurley, and for my kinesiology final, I will be explaining the biomechanics of a volleyball hit. The volleyball hit involves a powerful downward spike motion over a net with the aim of being unreturnable by the opposition. It is important to understand the biomechanics behind this motion in order to complete it correctly. Biomechanics is the science involved with the study of forces acting on and within a biological structure and the effects produced by such forces. The primary purpose of biomechanics is to evaluate the laws and principles of mechanics about human performance in order to gain greater, in-depth understanding and knowledge about specific details. It is important to have a wide understanding of the applications of physics into sport and on the human body, as physical principles such as motion, resistance, momentum, and friction play a part in most sports, including volleyball. The four key components of hitting a volleyball are preparation, takeoff, jumping height, arm swing, and hitting. In order to generate the greatest amount of power when spiking, a volleyball player needs to be able to use these forces together and make them into one flowing movement. I will now explain the biomechanics of these components in more detail. Newton's first law states that an object will remain at rest or continue to move with constant velocity as long as the net force equals 0. In relation to this, the preparation phase includes a running approach that is important to give the volleyball player maximum momentum for the height of the vertical jump in the takeoff phase. Momentum is the product of the mass of the player and the velocity of the approach, which in turn relates to the optimal momentum that can be gained for maximum velocity of height in that jump. The player exerts a force bigger than the present inertia, resulting in an increased running speed on approach to the jump. This leads to Newton's second law, which states the acceleration of an object is proportional to the net force acting on it and inversely proportioned to the mass of the object. Newton's third law states that for every action, there is an equal and opposite reaction. It is recommended to plant and take off quickly during an approach. This is due to the concepts of kinetic energy and potential energy. During the approach, the body has kinetic energy, described as energy in motion. Faster-moving objects will have greater kinetic energy. The goal is to transfer this kinetic energy into potential energy in preparation for the jump. If it comes to a stop, the kinetic energy will be less. Therefore, preventing jumping is high, since potential energy is the product of the mass of the player, gravity, and the height of the jump. The height is what determines how much potential energy can be attained. Arm swing. In performing the arm swing phase, the hitting arm is pulled back with the elbow and hand at shoulder height or higher. The hand is open and relaxed, with the palm facing away from the ear. The elbow then swings forward and is raised above the head. Then the arm and the hand swing over the top as the heel of the hand connects to the ball. The combined forces travel through the torso to the shoulders, arms, and wrists until the force is released onto the ball. This process assists the arm to store and release energy from the muscle and tendon at lower levels, meanwhile helping the trunk to move upward. Increasing the range of motion for the arm swing allows the arm to generate more energy, which is transferred to various body parts, which can improve the overall vertical jump performance. Long levels are another principle in place used to increase an implied force, whilst short levers are used for fast and accelerated movements. The combination of both long and short levers allows maximum force and acceleration to be applied to the volleyball during the arm swing. The spike combines these two levers. The long lever is made up of the radius and ulna, while the wrist is the short lever. When hitting the ball, it should be contacted reaching up high with the arms straight, elbow extended, reaching directly above or slightly in front of the body. The contact point of the ball and hand should be at the peak of the jump to gain the most power and accuracy. By using a wrist snapping type motion to direct the ball downward into the opponent's court. Newton's third law of motion, action and reaction force, and the conservation of angular momentum are used by the athlete to transfer power to the ball. If the angle the athlete hits the ball at is steep enough over the net, the spike may be unreturnable And to optimize the angle and the speed of the shot, the player needs to aim to be as close to the net as possible. The more joints used when making the spike approach means more muscles are there to contract and lead to more force exertion. The kinetic chain allows for the sequential acceleration from the legs, knees, hips, torso, shoulders, arms, elbows, wrists, and fingers, all possible joints for maximum efforts to contract and produce maximum force and power to be projected onto the volleyball. That is a breakdown of how to use biomechanics to hit a volleyball. This information also applies to other sports like high jump and basketball.